All right, let's take a look. We were doing factoring. I was calling it R4, but this is R5 in the new edition. We were working on factoring. We're going to continue that, and then we're going to hit the next sections, which I'm not even going to bother numbering because I don't know what the hell they are. I know we're getting through the lecture material, and I know it's going to show up by the 15th, the homework that's due on the 15th. I did receive an email from a student this weekend asking, or not this weekend, but this week, asking a reminder for in class for homework. I'm not going to remind you every week that homework is due on Wednesday. It's due on Wednesday. Just remember it. Make a calendar, write it down. It's due on Wednesday, but I will show you where you can see it. If you come to your college algebra pre-calculus course, you click on syllabus, it will tell you what's due on this very first thing. Due on the 15th is all of chapter R. I've rescheduled the dates because my chapter R is completely off of what the hell they're doing in my math lab. I have like notes for the 6th edition, and they changed it too much. And I didn't change them yet. And so like on the 15th, everything will be due for chapter R. We will be done with everything in chapter R by like, I don't know, what's today, the 2nd? We'll have it done by next Thursday. So the 9th, we'll be done by then for chapter R. So you'll have 6 days, basically, full 6 days, maybe 7, to get the rest of it knocked out. And you can see the homework schedule there. It's also in my math lab, which you can either type my math lab directly, or if you're not on a Google Chrome like Chris is, a Chromebook, he was telling me the link doesn't work on a Chromebook. But if you click on my math lab link and you click in open a new tab, it takes you to Pearson directly. And I will just sign in and point out where you can see the homework there. Assignments. The due dates are over here. And they are in due date order. And in the order I'm teaching them. So that's where you can find homework due dates. I won't remind you every week that your homework's due on Wednesday. You're adults now. And I will hold you accountable to being adults. All right. Back to some lecture notes. Where were we? We had just done some trinomial factoring. Let's do another. Did I make another fun one? I think I had another fun one here. What happened to my fun one list? Rude. There it is. So we're fucking it up. 8x squared minus 24x minus 80. And so as a reminder, we always want to look for a greatest common factor first. I can see right away without a lot of doing any calculations whatsoever that they are all even numbers. So I know it's at least divisible by 2. So maybe I could start checking bigger numbers. And the way I'm going to decide what to check is this number can only be done as 1 times 8 or 2 times 4. And I know a 2 is already, which could have, yeah, it could be 2 times 2 times 2 and only have a 4 total. So I know 1 2 is already in it. Let's check. If I take out a 2, what do I have? I've got 4x squared minus 12x minus 40. And those are all even also, so I could take out another 2. If I take out another 2, I have 2x squared minus 6x minus 20. Shit, I got another 2 I can take out. I can take out all 8. X squared minus 3x minus 10. And outside that goes my 2 times 2 times 2 is 8. Or you can do that table that we talked about on Tuesday. So this is a way to speed up that table. Pick the smallest number, the one that has the least number of factors, and check to see if the numbers in it go into everything else. That's what I did here. 8 was the smallest, has the least numbers. All right, so now I've got 8 times x squared minus 3x minus 10, and I can ignore the 8 for now. And this should look like something that you guys probably saw in high school. In fact, where most algebra teachers start this topic. They start the topic when there's no number in front of x squared. What I showed you still works. 8 times c is -10, and b is -3. And I know that's what they do in the diamond method. I don't know if they put the -10 here or the -3 here or vice versa. If you're familiar with the diamond method, there's other forms. But there's not a lot of things that multiply to -10 that add to anything, to be honest. What are my options for -10? I got -1 and 10. I've got -2 and 5. I've got 2 and -5. And that looks like it right there. So don't forget your 8. And we have x squared plus 2x minus 5x minus 10. We do our grouping. I've got -5 times x plus 2. And I got another x plus 2, and I got times x. So this ends up being x plus 2, and then x minus 5 with the 8 out front. Now, if you learned this in high school, how to do it with a 1 in front, you probably didn't do this step right here. Because there's some magic stuff. Magic happens when the x squared term has a 1 in front. My magic is the two numbers we had here, 2's and -5's, are the same numbers you have right here. That's our magic. Once you found what fits the criteria, or meets the problem, drop them in to, maybe I'll make this a different color here. Here, question mark number 1 and question mark number 2, including their signs. If I do that here, I had 2 and -5. I drop those in, I have x plus 2 and x minus 5. And I still got to remember I had the 8. So some magic happens when the x squared term is 1. A lot of teachers lead with that, but it really makes it hard for students to figure out how to do the harder ones with numbers in front if you start there. It's hard. I know it is. It's much harder. Doing this whole figure it out and just drop it in like it's a puzzle piece is easy. But, well, compared to the other way, right? Why are you staring at me, Senzi? Okay, that'll work. Daydreaming about something else completely besides math while looking at me is much better than, like, maybe I had, I don't know, had a fly on my forehead and didn't notice it or something, you know. I don't want that. That's lame. All right. I'm gonna give you guys one to do. All right, Erica, what did you get? You got x plus 2, x minus 15. Did anybody else get that? Or did anybody else get something different? What'd you get? And what's your handout going for? Oh, did anyone get something different? Are you good with that? Are you sure? That is it. A lot of times people look at this, I'm surprised. Either I'm guessing some of you are not telling me what you got, or a lot of you didn't do it, because the first guess of looking at this is to think 3 and 10. Because 3 and 10 add to 13. But the problem is if you do 3 and 10, they multiply, one of them has got to be negative, and that part's overlooked. 3 and 10 don't work. So make sure, if you did 3 and 10, now I gotta simulate someone doing 3 and 10. If you had said like minus 3x, minus 10x is usually what happens, and then minus 30. Well, when you do the grouping, it should fall out that something's wrong. That's if you do the grouping. If you just go jump straight to the answer and say this is x minus 3, x minus 10, well, that's not going to show you right away. I can't get an x minus 3 here, though. The best I can do there is an x plus 3. If I tried doing minus 3 and said this is 10, when I multiply it in, it's wrong. So, pro tip, always multiply a factored thing out afterwards. The factoring is the hard part. The multiplying and adding shit together, you guys know how to multiply and add. That's much easier. It doesn't take you as long to do, and you can check your work. All right, so we did polynomials with 4 terms. We've done trinomials. Let's take a look at some binomials. There's only 2 we really have formulas for. 3. We have a squared minus b squared. We have a cubed minus b cubed. We have a cubed plus b cubed. This one is a minus b and a plus b. These 2 have identical setups. So I'm going to show you the setup and show you what changes.
To do that.
They have identical setups other than some few spots where there's signs. This sign for the cubes matches the one in here. That one's a match. And the thing that goes over here is the opposite sign. The problem is these are, if you can memorize them with flashcards pretty quickly, especially because these, I mean, these 2 are the harder ones, but they are pretty close to each other. So like you learn one, you kind of learn both. And if you're uncertain when you do it, you can always multiply it back out and show that it works. So let's look at some examples. Let's do 64r squared minus 49. When you have only 2 terms, 1, 2, it's got to meet one of these or it's not going to factor. Okay, so if like the variable has a square on it, you're trying to do this a squared minus b squared one. If it has a cube on it, it could be either one. It's just depending on what sign's in the middle. So I see the r is squared. I'm thinking it's going to fit this a squared minus b squared. The question is, how can I make that match? Well, 49 is 7 squared. That part's pretty easy. What gets squared here? The r clearly does, and the other number is 8. So if I want to line this up with a squared minus b squared equals a minus b, a plus b, I got to kind of match these up. 8r is a. So where I see the a, I can throw in the 8r. And b is 7. So wherever I see the b, I'll put the 7. And then just one has to be positive and one has to be negative. I can do that part in either order. The reason why I tend to teach it like this, with the a minus b first, is because it matches the idea with the cubes. Whatever sign's in here should be the sign in the first thing. But on this one, it doesn't matter. These two come to the same value. Sometimes you get lucky and they're simple. Homework might do you dirty like that, but I'll make sure I'll do the right by you. I'll make sure you know this material by giving you something harder than this on the test. Because I care. I want you to be able to say, when you walk out of this class at the end of the semester, I fucking know some algebra. I'm good at algebra. Right? I didn't learn no weak soft shit, no low high school level shit. What are these two things? What things are squared here? Y and 2, right? So I just do the y and 2 in both spots, and one's negative and one's positive. That's all the holding hand I'm going to do. Let's go. Let's get rough. Which one does this fall under? Is it a cube or a square? So this is something to pay attention for. U to the 6, or any variable to the 6th power, can be written two ways. I could write this as u squared cubed, or I could write this as u cubed squared. One of these is going to lead to the cubic one, and the other one's going to lead to the square one. And so if you see 1 to the 6th power, well, first off, you can either check to see if this is a cube or a square, or check over here. I can't write isn't a cubic one. So it can't be the cubed one. It can't be that. Because y to the 4th, I can't make this y cubed in like a, or I can't make this. There's nothing I can put in here that I'm going to cube that you're going to want to work with. So that doesn't work. So we're going to have a u cubed squared. So I'm looking for what number squared makes 169. $13. What number squared makes 144? 12. And what would be y to the 4th? How do I get that down? What's squared to make y to the 4th? Y squared. You can just divide on these, you just divide the exponent by 2 and check. And so this is my A and this is my B. So when I do A minus B and I do A plus B, I have 13u cubed minus 12y squared times 13u cubed plus 12y squared. Hit one of the cubic ones. Let's go x cubed minus 8. Now I see a cube on the x, and now I got to pick one of the cubic ones. The sign tells me which one I need. On the 8, the 8 tells me I need the negative one. So I am looking for writing it in this form. Which means I need to know what A and B are. I can think the x is the cube thing here. 8 is 2 cubed. So my A is my x, and my B is my 2. And so if I follow this formula, I've got x minus 2 there. I've got x squared plus, I'm going to leave it exactly like it is, just to illustrate ways to go about it. When you plug these in, you should probably put these in parentheses. Now this one is going to be easy because the parentheses aren't really needed. You can tell right away what that's going to be. X times 2 is just 2x. It doesn't take any exceptional thought. But these do get uglier. You guys ready for more? We do the hard ones in here. Everything else is going to feel easier. If you need that longer, you need to say something. Or anyone's, are you still writing? Oh. Erica, you good? Yeah. You're the only one kidding, and that's why I'm asking. Let's try 27 t cubed plus 1,000.
Hello?
I'm here. Hi, how you doing?
I am stuck on another homework question.
Well, that's going to have to wait till after lecture.
That's okay.
You can always click on the Ask My Instructor and he'll email me, and I will answer it when I'm not lecturing.
Okay.
Okay. That goes for any of you. When you're doing the homework, if you're stuck, there's the ask for help or something. One of them is Ask My Instructor. It will send me the exact problem you're working on and give you a little room to like type a message. You get like, this is where I'm stuck. And tell me where you're stuck. You know what that tells me? Chris is doing homework right now rather than paying attention to my lecture. Shame.
I'm paying attention. I'm doing both.
Okay. I hope so. I don't want to have to give you an F. It's only been, what, 3 weeks? It's fucked up. I think I'm gonna give him an F for fucking doing his homework. That's a terrible policy. You're doing your homework? All right, so the T cube tells me I got a cube, hopefully. If I can't write it as a cube, it might be a done deal. Can I write this as something cubed? The plus tells me it's a plus, and then something else cubed. What can I use? I can use 10 there. What about the first one? 3t. Okay, so when we do our first parentheses, the first parentheses is always easy as hell. Just drop them in. No magic. This is why I put a curl on my t's, because when you get a t and a plus right next to each other, that's just fucking confusing if you don't have a curl. All right, now this is the part where I recommend putting this shit in squares. And then this one was a plus, this is a minus. I've got 3t times 10. And then this one is 10 and then squared. There's a lot of stuff going on in that parentheses, so it's easier just to take one extra step and write that stuff down. 3t squared is 9t squared. And then I've got 3 times 10 is 30, so minus 30t. And 10 squared is 100. All right. I don't think that's hard enough. Oh, it's gonna really bake your noodle. This one's actually not too bad, but it's still gonna bake your noodle. This is technically something squared minus something squared. Yeah,
Is that the zero or the CC?
it's 2c minus 3d. I was in a Zoom lecture today at noon with the other math teachers and the dean of the math and science and engineering departments in there. And he wears glasses and he's sitting in the back of the room. Like they're on campus, some of them are on campus. He's sitting in the back of the room and then I see him appear on Zoom. I'm like, look at you lurking on Zoom. He's like, I can't see the board very well from back here. I'm like, then I'm going to tell you what I tell my students. If you can't see, move your ass to the front row. He's like, oh hell, you got me. He didn't move, but I'll see. I haven't seen it in this class, but other classes, someone doing this. I'm like, if you're fucking working that hard to see, just move up. There's always empty space in the front. Always. What goes in these parentheses? The left one's kind of easy. It's already there, right? What about the right one? 4f. So if I follow my pattern, that whole thing is the A, and that's the B. So I'm going to do A minus B and A plus B. 2C minus 3D, and then minus 4F. And then 2c minus 3d plus 4f. Yeah.
Or you don't have to put the 2c minus 3d in parentheses inside the 1
On this one, you don't really need it because it's in front. If this was the other way around, if this was, let's say 16f squared minus 2c minus 3d squared, I would have 4f squared minus, again, the 2c minus 3d squared. On this one, I would want to do parentheses because this minus here, when I do it right here, is going to affect everything in B. So I would do 4f minus 2c minus 3d times 4f. The plus one doesn't matter. I can do the plus one, can stay the same. It's just that negative one that really fucks it up. Because when I distribute that negative, the 2c is not the only one that changes sign. I got to distribute it to the 3d as well. I still feel that this is too easy. More power. Yeah, I'm a sick fuck. You guys ready for more? I'll leave that there. I know we're gonna need more room, so I'm just gonna go to the next page now. Now, this has 4 terms, so by the logic of what I've been telling you, we should do the 4 terms thing and try to group. The problem is only one thing here has a y. So it doesn't matter what I group the y with, but here I try to do 2 pairs, that y doesn't have something show up in the other pair. So, see that? This is my only y in all of it. Which means if I'm gonna pair it, maybe it can't be paired as it is, like two pairs of 2s. Maybe the grouping isn't 2 and 2, maybe it's 3 and 1. Dun, dun, dun. Can I factor this? '81 made this pretty easy. How many combinations of 81 do you know? What's the first one that jumps to your head? 9 and 9, hopefully, is the one that jumps in your head. Otherwise, start reviewing the times table. It will help you substantially in this class to know the times table. 9 and 9 does add to 18. And so we can just drop them in. That would be how we factored that. But that shows x plus 9 twice, which means I have that. In fact, if Christopher's working on factoring, he might have got to a problem like this and said, I don't know what was going on. That might have been what he just asked my instructor on. Because he told me earlier he was working on the factoring moment. Since I'm not done with the factoring lesson, this might be it. If it's not, this isn't my final form either. It gets harder. I promise. What do I got going on here? If I write this as 5y squared, and I've got x plus 9 squared, sure as hell looks like I got the difference of squares. That's what this is called, difference of squares. Difference is subtraction, squares is obvious, hopefully. Which means I want to do the a minus b and a plus b. I'm going to have x plus 9 minus 5y and x plus 9 plus 5y. Bennett, you asked me about parentheses earlier. It doesn't hurt if you put them in. You'll just find out on the next step that they wouldn't have been needed. I don't want to discourage using parentheses. That's always good. Better be safe and cautious. And race ahead. All right. And nothing, I got no squares left, so there's nothing else to do. Okay, there's one for you guys. Let's see if everyone's getting started on the right page. What should I do first here? Anyone have any ideas? I'm betting a lot of you are stuck right here.
Didn't you just go 2 Y's and the 25? How did I go with the
Group these together? I like that. So if I do that, what should I do?
10, negative 10, 20. But I got stuck was the negative one still.
The negative's throwing you off, isn't it? Even down to the -10 and -25. That should be positive. So. Do you get an idea?
Make all of them positive and put the negative out.
That's a great idea. Did you guys hear what he said? He said, take that negative out, factor it out. And now we've got something that will fix that. That very problem is now fixed. You daydreaming or now you're just checking out my gorgeous hair? Hopefully that helped get some people past I'm stumped spot. Hopefully you got that down to y plus 5. And this is 2x squared. So I'm going to have 2x minus y plus 5 times 2x plus y plus 5. And you want to distribute the negative in this one. You'll have 2x minus y minus 5. And now this set of parentheses is on the inside there is not important. I think I kind of want to go big or go home right here. I think this is a go big or go home kind of moment. Leave that up there in case anyone's still writing. It looks so easy. It looks so innocent. You know what? Let's kick it up a notch. Let's make it 64. Because 1 was too easy. Okay, so what does the 6th power tell me I can do? I can do it as a cube or a square, right? Which one do you guys want to explore? Who wants cube? Who knows the cube root of 64? It's 4. As long as you know what the cube root of 64 is, it's a very good spot to start. So most people said cube. We're going to start with cube. So I want to write this as something cubed minus something cubed. So 4 goes in there. What goes in the first one? X to the power of 2. That X to the power of 2 works, but yeah. Because I can't remember the last time I heard someone say it in that manner. Not even X to the 2nd power. You went with X to the power of 2. I don't know that I've ever heard that combination. Nothing wrong with it, it's correct. All right, so my cube formula. I think something to tell you've got to memorize. It's worth writing down the generic form before you start filling shit in. This gives me x to the power of 2 minus 4. And then I'm going to use brackets and parentheses on this one. Because there's some stuff going on here and I don't want to fuck it up. And even someone has got years and decades of, well, let's not go plural there. Decade and a half of working with math an awful lot. I still fuck up. So I'm going to use parentheses. My A is x squared. And my B is 4. So I have x squared minus 4 times x to the 4th power plus 4x squared plus 16. All good? Are you guys ready for the next one? This one's not done. Told you, go big or go home. What can I do with it? If you have something where you have something to the power of 2 or larger. Thank you, Eric. I'm going to start doing this all the time to the power of 2. You should check to see if anything else applies. Does anything else apply? This is a difference of squares, isn't it? This is x squared minus 2 squared. Which means I can split that up into x minus 2 and x plus 2. That's the best you're going to get with this one. Where is it? This is the best we're going to get going this direction. I don't know how to factor this. I know it factors though, because I know the answer here. So believe it or not, you're not going to find a way to factor it. But we started off with cubes. Let's start off with squares. I have x cubed squared minus 8 squared. So the square one's pretty easy. One in the first parenthesis, we do the first parenthesis one in the front and the last parentheses in the back, and we put different signs in them. But we already know that's not done because we already found something that had a smaller form. This is cube, 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 cube. This is x cubed minus 2 cubed times x cubed plus 2 cubed. So maybe I'll use 2 different colors here. I'll go, let's do this is a cubed minus b cubed. And that'll give me a minus b times a squared plus ab plus b squared. And then maybe I'll use green for the other one. A cubed plus b cubed That formula is a plus b. A squared minus ab plus b squared. Now, the a's in both of them are all x's. The b's in both of them are all x's, or both all twos. So everywhere I see an a, I can put an x, and everywhere I see a b, I can put a 2. And if I rewrite it in the order like the first one had, I'll point out something that you will never, ever, ever memorize unless you're got like an eidetic memory. All I did is move the x plus 2 forward. X minus 2, x plus 2 is right here. Which means this thing right here factors to this thing right there. But it doesn't matter how many trinomial methods you do, we don't really have one that's it doesn't work. Because the squared thing is fucking it up. So that's the actual final correct answer. So, pro tip. If cubes and squares both work, start with the squares. And not even that is my final form. We've got more fun shit in factoring. As I said, when we did the list on, was it Tuesday? Did I start on Tuesday on it? I said sometimes you have substitutions come into play. So let's check out a substitution. This was kind of neat, right? That you do it 2 different ways, you get 2 different answers. I think that's kind of neat. Maybe I'm just amazed by stupid shit.
The top one, you can just like spread out the percent, like the next word, square, you can say square.
What do you mean?
Square.
Well, how do all the methods we have for factoring a trinomial end up with a set of 2 by 2. Both of these have 3 and 3, and so the patterns, like if you could figure out how to do this, maybe. Could we write this as, because I can't write this as, this isn't x squared plus 2x squared. That's not that. That doesn't, x to the 4th plus 4x squared doesn't turn to that. So, and we don't even have a squared formula 1 to work with. So like if you can figure out a way to, like a formula that works for you all the time, share it, spread it through the world, and get your name on some books. I'm sure with a little bit of effort, I could write up a formula that figures it out. No one does, it's not worth doing. How often do you have a cubic or something to the power of 6 minus something else to the power of 6? Not often. That's not my final formula. Let's bring it. I wish I could do them. It just doesn't sound as good. I don't have that deepness. All right, so we have two options. We can multiply all this shit out. Gather it all together. And then try to factor it. It will work. The other idea is, which I would encourage you because it's quicker, a lot quicker, is go, if I call this like, I don't know, smiley face, call that smiley face squared, where smiley face is 3x plus 1. I could put a smiley face here. Then I've got plus 10 smiley faces, minus 25. And now this looks like a trinomial thing. Maybe smiley face doesn't work with you for you. Maybe use a y. This is factorable using the techniques we've done. When you factor it, you are going to end up with, let's see, 4y minus 5 and 2y plus 5. In the interest of saving time for the lecture. But we didn't start with y. So, if you didn't start with y, you shouldn't end up with y. Put this shit back in. This is 4 times 3x plus 1 minus 5 times 2, 3x plus 1 plus 5. And you'll want to multiply that out. 4 times 3x is 12x, and then I've got 4 times 1 is plus 4. And I'm just distributing these right here. We clean this up, we get 12x minus 1 times 6x plus 7. I'm gonna let you guys try one. This will be our final factoring one before we move on to the next section. So let's give you guys, fuck it, let's keep going with the 3x plus 1. Why not? Okay, hopefully, what we tend to use rather than y is we tend to use u. You'll get, if you go on to calculus and stuff, you'll get used to using u as a letter to substitute, because we don't really use u for anything else. U has got, it's a lonely place. So we'll use u for my 3x plus 1. And this becomes u cubed minus 27. And now this is the difference of cubes. U cubed minus 3 cubed. Which means I can do that formula. But we didn't start with u, so we're not going to end with u. I've got 3x plus 1 minus 3 here. And here I've got, what is this? 3x plus 1 squared plus 3 times 3x plus 1 plus 9. And we generally want to write that shit all out. So this is going to be 3x minus 2. This one's got some work. And this does not turn into 9x squared plus 1. This part, the 3x plus 1 squared, is 3x plus 1 times 3x plus 1. I'm going to give myself a lot of room. If you write that out, you're going to get 9x squared plus 6x plus 1. And then I'll do this set here. 3 times 3x is plus 9x. And 3 times 1 is 3. And when I gather them all together, I get 3x minus 2 times I've got a 9x squared. I've got a 6x and a 9x, which makes 15x. And I've got a 1 plus 3 plus 9 is 13. And I'm missing x there. There we go. I'm gonna hit stop record and start record again, because we're switching to another chapter. And I like to break it up a little bit.